Good morning, students. Here I want to give overview of the differential equations. Means up to now we completed 12 lectures on differential equation. In the 12 lectures what we discussed, just I want to give overview of that. Within 10 minutes I will give overview of the differential equation. Just listen. So here you have some practice problems. After discussion of that overview of the differential equation concept, I will explain how to do the problems. Then in that way you have to solve the problems. Okay, so first let us see here. So you can observe here. So tell me which topics we discussed in the differential equation. How many topics we discussed? First of all, what we discussed, order. What is the order of the differential equation? What is the order? The highest derivative. The highest derivative present in the differential equation, that is what order. So we have to take second derivative, third derivative, like fourth derivative. In the differential equation, you have to see that which is the highest derivative. That order is nothing but order of our differential equation. Next we discussed about degree. So what is the degree here? Degree means the highest power of highest power of highest derivative. Sorry, the highest power of highest derivative means what here? What I am saying here, first you have to find order. Order means what? The highest derivative. For that highest derivative in the differential equation, what is the highest power? That is our degree of the differential equation. Means what there here? And you have to see that the differential equation should be free from radicals, fractions, and it should be polynomial of derivatives. We have to see that first of all the differential, whenever for order no need to check all those things, only you are checking about while you are finding the degree of differential equation. First, whether the differential equation is free from radicals, fractions, is it standard form of polynomial of derivatives or not. If it is like that, then you have to see that what is the highest derivative. Then for highest derivative, what is the highest power? That is our degree of the differential equation. That concept we discussed. Next, what we discussed, formation of a differential equation means if the curve is given. So if a curve, any solution like a curve is given, if curve is given, then how to form a differential equation for that curve. Means first of all, what is the first point? You have to see that in that curve, in that solution, how many arbitrary constants are there. You have to check about that arbitrary constants. The number of arbitrary constants you have to check. So how many arbitrary constants are there? That many times you have to differentiate. So your second step is what? First, for example, two arbitrary constants are in the solution. You have to differentiate twice, like that. Differentiate that many times. How many arbitrary constants are you observed in the solution of the curve? You have to differentiate that many times. After differentiating, you will get some equations. By using all those equations, third step, you should eliminate arbitrary constants. Whatever arbitrary constants are present, you have to eliminate arbitrary constants. You will get one equation, it contains derivatives. That is our in that formation of differential, there is no arbitrary constant. You should eliminate arbitrary constant. In that one equation, it contain only derivatives, dependent variables, some like that. So that is our required formation of differential equation. Okay, so this is the how to form a differential equation. Just a simple 3 steps. First, you observe how many number of arbitrary constants, that many times you have to differentiate. By using all those equations, you should eliminate arbitrary constants. You will get finally one equation that contain derivatives. That is our required formation of differential equation. Okay, next we discussed the solution also. So you already discussed general solution and particular solution. So what is general solution? What is particular solution? First of all, what is a solution? Solution means relation between dependent variable, independent variable, constant, and it should satisfy. Solution should be satisfies the given differential equation. It is a relation of dependent, independent variable, some constant. So it satisfies the differential equation. That is called solution. Again, solution two types: general solution, particular. General solution contain arbitrary constants. Arbitrary constant like C1, C2, something like. You have arbitrary constant in the general solution. But in the particular solution, you does not contain arbitrary constant. How you are getting particular solution? For getting particular solution, you should first find general solution. After finding general solution, you should give some particular values to the arbitrary constants. Then you will get particular solution. Okay. So means how you are getting particular solution? It is obtained from general solution. But you give some for arbitrary constant, C is equal to 1 or C equal to 2, something like that. If you give some particular values to the arbitrary constant in the general solution, it will be obtained particular solution. Particular solution does not contain arbitrary constant. Does not contain arbitrary constant. For arbitrary constants, we are giving some particular values. That's why I call particular solution. Does not contain arbitrary constants in the particular solution. It is obtained from general solution by substituting some particular values to the arbitrary constants. This is what particular solution. You have the doubt, madam, how you are getting C values? Because in the problems they will give some conditions. If you apply the condition like y is equal to 1 when x is equal to 2, something, if you substitute those conditions, you will get the C values, arbitrary constants values you will obtain like that. Okay. So whenever they are asking particular solution in the question, they will give the conditions also. If you substitute that condition in the question, you will get some arbitrary constants values. Substitute that C values in the general solution, particularly C value, you will get particular solution. Okay. So this is what is meaning of solution. Next, okay, first how to find solution. So next topic is what is general solution, what is particular solution. But if differential equation is given, how to find solution, that we have to, the next topic we discussed. How to find the solution, how many ways we discussed to finding the solution for given differential equation. First of all, the differential equation should be, you have to see that first order first degree, means whatever the given differential equation, you have to see that should be what, first order first degree. To find the solution of first order first degree, we have given some 4 methods. By using those methods, you have to find the solution. But when we apply which method, according to given differential equation, which method is applicable, we have to decide. Based on the condition requirement, we have to decide that which method is applicable for the given differential equation to find the solution. Okay. So first of all, I will tell you how many methods we discussed to find the solution. So already we discussed some 4 methods now. So I think already you remember. Tell me, first method is variables separable method. Yes. Yeah. Next which method is applicable? Homogeneous method, homogeneous differential equation. Then which method? Homogeneous method. Next, non-homogeneous. If the given differential equation is non-homogeneous differential equation, how to find the solution? If it is linear differential equation of standard types, you have 2 standard types. Yes. Okay. First of all, what is variable separable method? First of all, you have to see that the given differential equation is of first order. First order first degree means it should be in the form of dy by dx is equal to f of x comma y. In that you can observe that what is the derivative, highest order is 1, degree is 1. So first order first degree. The differential equation of this type, if you find in the question, if they are asking solve, You have to check which method is applicable. How to check? First, whenever they given question, try to solve by using variable separable method. If it is not possible, just go to homogeneous. If it is not applicable homogeneous, then go to non-homogeneous. If it is non-homogeneous also not applicable, then you have to go to whether is it linear differential equation or not. You have to check one by one. While you are doing the problems, you have to, because they doesn't mention that in the question, your exam, if you go, they doesn't mention that by using this method you have to solve the problem, by using this method you have to solve the problem. They doesn't mention anywhere. Just they are asking solve the differential equation. If they mention, not a problem. But most of the cases they given solve the differential equation. You have to decide which method is applicable to solve that given differential equation. That I want to discuss once again here. Variable separable method means what here? Whenever in the differential equation, if it is possible to separating x variable, y variable, whatever the variables are there in that, if it is possible to separate the variables x and y, separating, if it is possible, then you have to apply this method. How applying? First you have to separate, then you do integration. You will get the simplification, you will get the general solution here. So means what I am telling here, if it is possible, like f of x, x terms keep at a time and y terms keep at a time. If it is the separating is possible, here x terms is one side, y terms is one side. If it is possible, the given differential equation is like that, then you do integration separately, you will simplify, you will get the general solution. It is very easy, variable separable method. Even it is useful in other methods also while you are doing that applicable that method. Yes. Next, for suppose variable separable method is not possible directly, you should make reducing into variable separable form also sometimes. Means you have to assuming some x plus y equal to u, something like you have to reducing into variable separable form. Okay, already discussed that concept also. Okay, like this. If it is not possible both, means if you understand that it is not possible directly variable separable, then you have to see that whether is it given differential equation is homogeneous differential equation or not. What is homogeneous differential equation? What is homogeneous differential equation here? Homogeneous differential equation means what? The given differential equation should be in the form of dy by dx is equal to f of x comma y by g of x comma y, where the numerator, the f of x comma y function, the denominator g of x comma y function, both functions have the same degree. If both should be homogeneous functions of same degree, then we say that the given differential equation is homogeneous differential equation. If it is homogeneous differential equation, you have again like two methods, not two methods, depending on question. Which way we have to solve in homogeneous differential equation? For example, if it is in the form of dy by dx in the question, you have to substitute, put y is equal to vx. Then dy by dx is equal to, differentiating on both sides, you will get x dv by dx. Otherwise, if the homogeneous differential equation is in the form of like dx by dy form, dx by dy form is homogeneous, but instead of y by x, if it is dx by dy form, then you have to substitution is what here, x is equal to vy. Then differentiate means dx by dy is equal to v plus y into dv by dy. Okay, so means instead of dy by dx you have to substitute this, instead of dx by dy you have to substitute here and put y equal to vx in the total function and simplify. Here also you will get somewhere you have to apply variable separable method in the middle while you are doing the problem. Here also you are applicable somewhere variable separable method. Hence, there you have the v x terms are by using variable separable. Here v y are variable separable method is applicable somewhere while doing simplification of this. Understood? Okay. So then you will get our general solution. This is the way of doing if it is homogeneous differential equation. This is the method. Next, which methods we done here? Next concept is what? Non-homogeneous. Already I told you in non-homogeneous differential equation, how to identify whether the given differential equation is non-homogeneous or not? It should be in the form of dy by dx is equal ax plus by plus c by a dash x plus b dash y plus c dash, and a, b, c, a dash, b dash, c all are constant, and c, c dash should not be both are zeros at a time. In that case, I can say if it is like this, I can say non-homogeneous. Even though after identifying given is non-homogeneous, again you have three methods here. Yes or no? Which case you have to applicable? Based on that case you have to do the problem. So one is b equal to minus a dash. Second one is a by a dash is equal to b by b dash. Third case is if a by a dash, b not equal to minus a dash and a by a dash not equal to b by b dash. Then you have to apply third case. Okay, let us see. So what I am doing here, so first case, so even though after identifying the given differential equation is non-homogeneous, you have to check which case is applicable, case 1, case 2 or case 3. Suppose b equal to minus a dash, you have to apply, which method is applied here? B equal to minus a dash means in the case of b equal to minus a dash, cross multiplication. You have to do cross multiplication. In that you will get one form, dxy is equal derivative, total derivative of xy is equal to x dy plus y dx. Somewhere while you doing simplification, what you will do in this method, how I am doing in this method, cross multiplication. You should do cross multiplication. In that cross multiplication, while you are doing simplification, you will get somewhere x dy plus y dx form. You have to substitute derivative of xy total. Then you do integration, integrating on both sides. So then you will get our general solution. It is very simple. You will get answer easily. But in the second case, so if b not equal to minus a dash, then I am checking that the ratio is it same or not. Means a by a dash is equal to b by b dash or not. If it is a by a dash equal to b by b dash, what is that common ratio? Let us suppose some m. Like you have to assume some common term will be there. Whenever you have common ratio, if the ratio will be same, a by a dash is equal to b by, in that case sometime you will get ax plus by equal to b. So which is common term in the numerator and denominator, there exists some common term. That common term you have to substitute some assumption like b. Then you have to do simplification like differentiating a plus b dy by dx is equal to dv by dx. Substitute instead of dy by dx is dv by dx minus a by b. Like that, if you simplify, again you will get our general solution after simplification of the substitution. Instead of ax plus by equal to b and dy by dx means dv by dx minus a 1 by b, like that. Then you will get simplified. You will get our general solution. Next method, case 3. In the case 3, what I am doing, in the both cases are fail. Case 1 is fail, case 2 also fail. Then you have to go to case 3. In the case 3, what happened? B not equal to minus a dash, a by a dash not equal. Means case 1, case 2 fails. Then we go to one method, that is translation. Means what you are substituting, small x is equal to capital X plus h. Small y is equal to capital Y plus k. I am translating that in terms of x capital Y, the h comma k. Then what happen if you substitute these values? You will get in that differential equation RHS, some term you will get like this, ah plus bk plus c, you are equating as 0. A dash h plus b dash k plus c dash equal to 0. After substituting these values in the given differential equation, you will get like that. If you simplify, you will get h comma k values. If you simplify these two equations, you get h comma k values. The remaining you will get homogeneous. Whenever you get making h plus bk plus g, these two equating to 0, you will get the remaining part homogeneous differential equation. By using the concept of homogeneous, you have to simplify everything. But in the final general solution, what you will do, instead of capital X capital Y, you have to convert that. Instead of capital X, you have to write x minus h. Instead of capital Y, y minus k. Because in the final general solution, the answer should be in terms of small x and small y. Whenever you get h comma k values, substitute here x minus h, y minus k. Instead of capital X capital Y, you have to substitute those values here. You will get our general solution in terms of small x and small y. Understood? Okay, so this is what about non-homogeneous differential equation concept. Just I am giving overview. Already explained everything in the previous lectures. Okay. Last method. What is the last one? Linear differential equations. Very important this concept. So what is the standard form of linear differential equations? Tell me, what is the standard form? You have two forms actually. So maybe the function is like dy by dx plus p into xy is equal to dy by dx plus py is equal to q, or dx by dy plus p into x is equal to q. If the standard form, the given differential equation first order first degree, if it is in this form, means what here? Where p comma q are either constants or functions in x variable. Okay, so dy by dx plus p into y equal to q, where p comma q are constants or functions in x variable. Which is the independent variable here? X. Which is the dependent variable? Y. So that p comma q function should be either constants or functions in independent variable. Okay, if it is in that form, I can say this is linear differential equation in y variable. It is called linear differential equation in x variable. Means which is the dependent x. That's why here p comma q are constants or functions in independent. What is independent variable here? Y. That's why functions in y variable. If you identify the given differential equation is like this form, then how to get what is the standard form, the general solution? First, you find integrating factor. First step is you should convert the linear given differential equation in this form. Then second step is find the integrating factor. What is the formula for integrating factor? E power integration of p dx. Why I am taking p dx? Because p is function in x variable or constant. After getting integrating factor, you have to find the general solution by direct standard formula, that is, what is the dependent variable? Y. Y into integrating factor is e power integral p dx is equal to integration of, what is here? Q, right side. And integrating factor, what is the integrating factor? E power integral of p dx into dx plus c. This is what general solution for the given differential equation in the standard form. Similarly, here also, if it is standard form, if you convert like this, second step, find integrating factor. How to find integrating formula here? E power integral of p dy. Why p dy? Here p is function either y variable or constant. Then general solution formula is what? Dependent variable. What is the dependent variable? X. X into integrating factor is equal to q into integrating factor dy plus c. Same like that. Okay, so not only this, sometimes you have in the form of Bernoulli equation. What is Bernoulli equation? Suppose Bernoulli means in the standard form either dy by dx plus py is equal to q into y power n. So this is Bernoulli equation in y variable, or dx by dy plus px is equal to qx power n. Actually here q is only function in x. You have extra term y power n. What you will do, you should convert into standard form of this. How to convert? You have to divide y power n on both sides. If I dividing by y power n, you will get like that. You have to again, after dividing y power n, you have to substitute some variable here. Try to convert in the standard form of this. Then you will do the same procedure whatever we done. Already I explained like this some problems. Okay, so here also x power n, actually q only function in y variable, you have extra term x power n, you have to divide on both sides by x power n. Then again you have to substitute here some value like we assumption something, you try to convert in the standard form. Then again you have to use the same procedure for solution. Okay, so this is what I want to say, all the concepts overview of some differential equation in entire chapter. So in entire chapter only discuss these things. By using these things, if you understand properly each and every point whatever I discussed up to now, then you can easily solve the problems. Very easily you can solve the problems. Now I will give some practice problems, go through that. Just I will give the clues how to solve. Then you have to do all the problems by yourself. That is just for practice purpose, how much you understand. Because in each topic, whatever I am telling, separately you can easily do the problems, but whenever in the exam hall, if I give the questions all at a time, you should identify which method is applicable. On seeing that question, you should identify. Understood? So that's why I am telling here first. Okay, so finding the, suppose it is our question paper, how to think in the exam hall. That's understood. How to think. What are the questions here? Order and degree of differential equation. So how to think order. So what is the highest derivative? What I discussed just now, highest derivative. What is the highest derivative here? It is first derivative, second derivative. First of all, is it standard form of polynomial of derivatives? Yes. Yes, there is no fractions power like that. So directly I can see the highest derivative is what here? Order is 2. And what is the power of the highest derivative? 1. So don't confuse. Here the highest power is 2, madam. F. But what? For which highest power we are seeing? Highest derivative power. What is the highest derivative? 2. For that power is 1. That's why the degree is 1 here. Understood? Yes. You have to think like that in the exam. Next question. How? Tell me the answer here. D square y by dx square plus 3 into dy by dx whole square is equal to x log d square by dx. First order. Tell me order. S. Speed up, answer. Yeah, very good. So what is the order here? 2. Because for order no need to check anything, because is it standard polynomial of derivatives or is it power like that? No need of check anything. Directly the highest derivative in the differential equation is 2. That's why order is 2. What about degree? Tell me here. What about degree? Think about degree. I will give 1 minute time. Think. Is it degree possible? Is it degree there? Yes? Yes? What's your answer? Yeah, very good. Not defined. Not defined. Why it is not defined? Because there is no power fraction, not like that. But here log d square y by dx square, here it is not a standard form of polynomial of derivatives. It is not standard form of polynomial of derivatives. It should be, first of all, you have, whenever degree means, if it is standard form of polynomial of derivatives, then only you have to see that the highest derivative like that. But log d square y by dx square, if you are expanding this, you are not getting the standard, because it have containing infinite terms. There is not finite terms. Finite term, then only I can say polynomial equation, but polynomial of derivative. But it is not like that. It contains infinite number of terms. That's why I can say degree is not defined. In this question, I can say that degree is not defined. Order is 2. Now, tell me here, root sin x is equal to d square y by dx square. I think order everybody can know. What is the order? Only madam one derivative, that is second derivative. So no need to check. That is the only highest. Order is 2. What is degree? Tell me what is degree? Whenever while you are finding degree, already I told you one step, it should not have fractions. The power should be free from radicals. Fractions here. Here it have fractions. You should squaring on both sides. If I do squaring on both sides, sin x is equal to d square y by dx square whole cube. Now tell me what is the degree here? 3. Here it is, this is you got as a sin x squaring on both sides. It does not contain orbit here, power is fraction. 3 is there. So the highest derivative power is 3. That's why here sin x is there, not a problem. It is, there is no derivative here. Yes or no? Just a sin x. It is a standard form of polynomial only. Okay, that's why. But here what happened? Log dy by dx is equal to a power x. So what is the order? Tell me what is the order? As what is the order? 1. Because the dy by dx is equal to, so the highest derivative is 1. What is degree? S. What is degree? Is it defined? Yes, it is defined. Directly it's not possible, but I can write this as dy by dx. This implies I can write as e power ax plus by. E power ax plus by is some like standard form dy by dx. Okay, so there is not like, it is not infinite, it is finite terms only. So I can write like this. According to logarithm properties, dy by dx is equal to e power ax plus by. Here does not contain derivatives, it is exponential standard form only. That's why the highest derivative power is 1, hence the degree is 1. In this way you have to think about order and degree. Okay, next, solve the following differential equations. How to solve the differential? Suppose I given in the exam hall this question. How to think? Tell me how to think. You have all, just now I discussed number of methods how to solve. You just say x plus y is equal dy by dx is equal to 1. So somebody think like this. Dy by dx is equal to 1 by x plus y. Okay, so somebody will write like this. Dy by dx is equal to 1 by x plus y. So I think it's not separating variables, not possible to separating x and y variables. I want to make into reducing into separable form, like substitution, x plus y is equal to u. Then 1 plus dy by dx is equal to du by dx. Like dy by dx means du by dx minus 1. Substituting here again. So like du by dx minus 1 is equal to 1 by u. Dy by dx is replaced by du by dx minus 1 equal 1 by u. Again plus 1, it like that. I can apply variable separable form, separating u variable, x variable. Then you will get the solution. Yes, it is correct. Okay. But somebody will think like this. How? For example, you can do like this. Or if I write like this, dx by dy is equal to x plus y as it is, I can write this as dx by dy minus x is equal to y. Now it is linear differential equation in x variable, last method, where p is equal to minus 1 and q is equal to y. Because dx by dy p into x q, like that. If you are reducing, like integrating factor, general solution, last method, in that way also you can do. What I am telling, if any problem is there, maybe you have one or more methods to get the solution. Which method you feel easy, which method you will get idea, you do that method, not a problem. For example, you can, if you do this method, if you are this, you do this method, anyway you will get the same solution. Answer should be unique, otherwise you have to verify. You will get the general final solution is x plus y plus 1 is equal to c into e power y. This is your final general solution. Simplify by yourself, because I am giving practice purpose. Just I will give the clue for how to think in the exam hall. That's what I am telling. So do this problem in both ways. Okay, you will get the unique solution. Think by yourself, do by yourself. I think you understand. Next, how to think this question? It is in the form of what? Dy by dx is equal to x plus 1 by 2 minus y. See, first how to think? Yeah, is it separating x variable, y variable? Yeah, directly, because 2 minus y dy is equal to x plus 1 dx. So separating x variables, y variable, then do integration, simplify. Very easily you get the solution here. Simplify by yourself. You will get the answer is x square plus y square plus 2x minus 4y plus equal 0. So that's what I'm telling. First, from simple to, you have to think bigger one. Like it is first I am checking whether is it separating variables of x and y, separating variables possible or not. Yes, it is possible. That's why I get the solution. Yes. Next I am thinking this problem. Now what I am thinking is, it first I am writing in the form of dy by dx is equal to x square plus y square by x square plus xy. Okay. So now, is it separating x variable, y variable or possible or not? I am just thinking. First method is that. But the x, if I go to dy like that, separating is difficult. It's not possible separating. Next I am thinking about whether is it possible homogeneous or not. Yes, it is homogeneous possible. Why? Because what is the power of x2? What is the power of y2? X power 2. Here x power 1, 1, 2. Means each term power is same. Numerator and denominator, hence having same degree. Then y. it is homogeneous differential equation. Hence you can apply the method of homogeneous differential equation. Which method? How to do that? Put y is equal to Vx, then dy by dx is equal to v plus x dv by dx. You have to apply that concept. You do simplification by yourself. You will get the general solution like this. How you will get the general solution? X minus y whole square is equal to cx into e power minus y by x. So if you do the simplification like that, you will get the general solution in that way. Okay, next this problem. Dy by dx is equal to 2x minus y plus 1 by x plus 2y minus 3. So it is in which form? Dy by dx. Is it possible variable separable form? No. Is it homogeneous? No. Actually, I am seeing this question, I understood that it is standard form of non-homogeneous, like ax plus by plus c by a dash x plus b dash y plus c dash form. Yes or no? Again, you have to see the cases. How? A is equal to 2, b equal to minus 1, a dash is equal to 1, b dash is equal to 2. Which is applicable here? Tell me. Here b equal to minus a dash. So you have to apply the first case. Understood? So cross multiplication, do the simplification of first case in non-homogeneous, you will get the general solution here. So what is, you will get the solution after simplifying. So your answer may be y square minus x square plus xy minus 3y minus x is equal to 0. Okay, you have to verify by yourself. Next, so how to do this problem? First, what I told you, have to write in the form of dy by dx form. Means whenever you will write this, you will get what here? Dy by dx means, first of all, you have to take this right side minus 2x plus y plus 1 by here 4x plus 2y minus 1. Okay, you have to think about a is equal to minus 2, b equal to minus 1 and a dash is equal to 4, b dash is equal to 2. So, what is a by a dash? See here, b equal to minus a dash, is it possible? No, b not equal to minus a dash. Then I am thinking about a by a dash, is it equal to b by b dash or not? What is a by a dash? Minus 2 by 4. What is b dash here? B minus 1 by 2. So 2 1 is 4. So hence it is possible. Second case you can apply. What is the second case? So in this problem what you will do? Common term. Which is common term? If I write 2 into 2x plus y. So you have to substitute 2x plus y is equal to some v. How to simplify, you will get our general solution. If it is like this problem, so here also which method is applicable, have to verify. So if you simplify this, I think you got the answer like the 2y plus x plus log of 2x plus y minus 1 equal to scale. Okay, next here also, what is a here? I'm looking, you understand x plus by plus a dash x plus b dash y plus c dash. A is equal to 1, b equal to 2, a dash is equal to 2, b dash is equal to 3. So what I am doing here, is it b equal to minus a dash? 2. Here 2, b not equal to minus a dash. First case is failed. Next, is it a by a dash? What is a by a dash? 1 by 2. What is b by b dash? 2 by 3. Is it equal? No. So first case fail, second case fail. You have to think about third case, that is put small x is equal to capital X plus h, small y equal to capital Y plus k, and remaining already I told you third method in the non-homogeneous third case. You have to simplify in that way. Okay, let it be. Next, now tell me how to do this problem. X plus 3y square dy by dx is equal to y. How? First, is it possible variable separable form or not? Is it possible? Tell me, is it possible of variable separable form? If I write dy by dx is equal to y by x plus 3y square, then x, y is at a time. So not possible. Variable separable not applicable. Is it homogeneous? No, because y power is 1, x power 1, here 3y square. So that is not homogeneous. Is it in the form of standard form? First, variable separable is not applicable. Is it homogeneous? No, because here y power 1, here denominator is x power 1, y power 2. So no. Is it standard form of non-homogeneous? No, because non-homogeneous should be x plus by plus c form like that. But it is not like that. Then I am thinking about our fourth method, linear differential equation. Is it possible to write like that or not? Yes. So if I write this as dx by dy is equal to, take this side, y take this side, it will become x plus 3y square by y. You will get like this, dx by dy is equal to x by y plus 3y. So I can write this as dx by dy minus x by y is equal to 3y. Now it is looking like standard form. What? Dx by dy p into x is equal to q, where p comma q are functions in y variable. It is so you have to apply integrating factor, general solution. Already just now I discussed. You have to apply that formula, will get the solution. In that way, hard to think about our in the exam hall, because variable separable not applicable, homogeneous is also not. It is not standard form. That's why try to convert, is it standard form of linear differential equation or not. Here also you looking like standard form. It is Bernoulli equation. On seeing you understand, na? Because dy by dx plus p into y is equal to q y power n, where p comma q are functions in x variable. On looking this question, you understand directly how to do this type of problems here. If you simplify this, you will, in this problem you will get the solution like x is equal to 3y square plus cy. Okay, so you will get the general solution like that. Next, in Bernoulli equation, dy by dx. How to do this? First you have to convert into standard form. How to convert standard form? Here, dividing by y power 6. So 1 by y power 6 dy by dx plus here 1 by y power 5, because y by y power 6 means y 1 by y power 5 x square. It is looking like 1 by y power 6 dy by dx plus y power minus 5 into x is equal to x square. Here it is function in x variable, here also x variable, here x, but you have to what extra term this. So what I am doing, y power minus 5, let us say u, then minus 5 into differentiating y power minus 6 n into x power n minus 1 dy by dx is equal to du by dx. So y power minus 6 dy by dx, for this I am replacing by minus 1 by 5 into du by dx, like that. Minus 1 by 5 du by dx. Here y power minus 5 u into x is equal to x square. Now it is standard form, independent variable, minus 5 multiply with minus 5, then it will be 1 only. Here minus 5, here minus 5, you can take like that. Finally the linear differential equation in terms of u variable. U is dependent variable, here x is independent variable. What is p here? If I multiply with minus 5, you will get minus 5x. P is minus 5x. Then q is equal to minus 5x square. Okay. So then you are, after that getting standard form, you will, it is in terms of u into integrating factor is equal to integration of this q into integrating factor dx. So please simplify. Finally substituting u value again. So in the final general solution, you will get the answer is like this. So what is our general solution here? Final answer is, after simplifying, do the simplification by yourself. Y power minus 5 by x power 5 is equal to 5 by 2x square plus c. This is our general solution for the given question. Okay, if you do the procedure like that. Now particular solution, yeah, up to now only general solution we discussed. So how to find particular solution? First of all, you find general solution. How to find general solution? First write dy by dx is equal to, how to write this as minus of x minus y. If I take right side, take cross multiplication, x plus y. Tell me now, I think looking like, is it homogeneous? I thought like it is homogeneous because power 1, 1, 1, 1. Same for numerator, denominator. So you can say homogeneous differential equation. So apply dy by dx means put y equal to vx. Substituting, after getting general solution by substituting these values, dy by dx is equal to v plus x dv by dx. But what condition is given after finding general solution? Substituting the general solution, y equal to 1 and x is equal to 1. After getting, first find the general solution. After getting general solution, substitute y equal to 1 and x is equal to 1. You will get the c value. After getting C value, arbitrary constant value, substitute that arbitrary constant value in the general solution again, then you will get the particular solution. What is our particular solution answer here? You will get the answer is like this. Log of x square plus y square is equal to 2 plus 2 tan inverse of y by x is equal to 5 by 2 plus log 2. So what I am telling here, just you have to do all these procedure, then you will get the general particular solution like this. First find general solution by homogeneous method. After that, substituting y equal to 1, x is equal to 1, we will get C value. Substituting C value in the general solution, we will get the final solution like this. This is what how to find particular solution. Next, last concept. We done almost all the problems that methods discussed. Formation. How to form differential equation? What is the first step? How many arbitrary constants are there? Only one. That's why we have to differentiate only once. Means dy by dx is equal to 2x plus 2. I think no need to do anything here because it does not contain arbitrary constant here. C equal to 0. So directly dy by dx minus 2x minus 2 is equal to 0. This is our final formation of differential because it does not contain arbitrary constant, it contains only derivatives. Understood? Here also, how many arbitrary? Only one, that is a. So dy by only once we are differentiating dy by dx is equal to a. Differential x is 1. Substituting this value in this equation by using eliminate arbitrary constant. A, substituting a is equal to y is equal to a means what? Dy by dx into x. So here also this is our answer. Yes or no? Similarly, y is equal to cos x. Only how many arbitrary? One arbitrary. Only once we have to differentiate, that is dy by dx is equal to differentiation of cos x is minus sin x. Yes. So differentiation of constant is 0. So dy by dx plus sin x equal to 0. So it is very simple. Actually, whatever I give you the questions, very simple problem. Only once we differentiate, and because I understood the concept. What is the concept? First identify how many arbitrary constant, that many times you have to differentiate. After that you have to simplify by given equation, eliminate arbitrary constant, then you will get our differential equation required. That is what our formation of differential equation. Okay, so is there any problems? Yeah, no. Okay, this is what I want to discuss all the things about overview of our differential equations and how to do the problems. So which method when we applicable depending on question, how to think in the exam hall, how to check the condition whether it is applicable or not. Okay, so all the best for everybody. Thank you. So this is what our final lecture in the differential equation. Thank you very much.